Hello, I know you are waiting for this week 8 quarter 1 video lesson. So, in our usual classroom setting, we will always start with opening prayer since we do need to ask for the guidance of God. Attendance checking, activities in the classroom will always be checked before we start so that you can always be guided of what activities you have left behind or what activities you need to do in the future in our during our activity. The drill for today for this particular week 8 had been posted already in your Google Classroom, so you have to visit that, and then we can discuss the hardship or difficulties you can encounter during our online session. For a start, I wanted to pick up or just get something that can help you find the square root of the following numbers. You can have your Android phone or maybe your computer. You just browse the net. There is an online calculator there, and maybe you can have your calculator itself. So let's have this one: square root of 36, square root of 2, square root of 81, square root of 64, square root of 50. So it's exciting in my place. All the sounds of the moving vehicles are already here, except of course the sea transportation. I wonder if it's going to be here anyway. So I think you're done. Let us see if you have the correct answer. So if your answer is square root of 36 is 6, then you got it right. Square root of 2, then there is it. There it is. Square root of 81, square root of 64, square root of 50. I just wanted you to look at the square root, the root of the given numbers. This will be our topic for today. I just wanted you always to observe so that, you know, our sense of sight can help us learn. Our senses can help us learn. Our sense of taste, our sense of touch, our sense of smell, our sense of sight. But in math, we usually use the sense of sight. Just like sometimes, because numbers cannot be eaten. Otherwise, it's so easy to teach about the numbers. Okay, so our main topic for today is principal roots and irrational numbers. This topic has been taken out from the quarter 1 module 7 of TEPED. So there are two lessons there. We have the principal roots and its nature, the rational and irrational. We talked about rational numbers before the last time. So week 7, it's all about rational numbers. Numbers that can be expressed as decimals, and the decimals can be terminating, or if not terminating, it's repeating. So we will talk about it, the other one, the irrational one, in this particular lesson. So we have lesson 2: determine between what two integers the square root of a number lie. So suppose there are one number, we are going to locate that particular root number into which two integers that one is going to lie or locate or be located. So we have the objectives: define principal root, describe principal roots, and tells whether they are rational and irrational. Determine between what two integers the square root of a number lie. Learning Competency Code. This is from the most essential learning competency of mathematics, the M7NS-1G. So, I don't know, is this one visible? But I want you to observe the way it is written. There is letters and sign. The sign there is considered the radical symbol. It's a symbol for squaring, for finding the root. C is for radical, the number you are going to look for, where the number you are going to look for the root. A is actually the index. B is the coefficient. It means if you cannot see any number or a radical number, for example, square root of 2 or square root of 25, there is no number next to square root of 2. The number there is 1. So that the coefficient is 1. Remember, 1 is always the coefficient or a number or a factor of any number. So B is the index or coefficient rather. No, the index. I'm sorry. I am being distracted. So B is the index, and B, it is somewhere telling you the root. So for example, the square root, you cannot see the number 2 as an index. If you cannot see that if you cannot see any number, it means 2. Because the lowest index in any radical is 2. So you can see 3 there. It means cube root. Means, for example, cube root of 8. You're going to think of a number. You're going to multiply by itself 3 times. For example, 2 times 2 times 2. It's actually the root, the cube root. Now, for that one, so we will talk about more on radicals on the next chapter or module or the upcoming modules. But today, we're just going to focus on rational and irrational. Don't worry about this. So, let's get on thinking about first the different words that we need to unlock or that we need to identify or define or give meaning. Remember, in math or in any other subjects, it is always good to know the meaning. Sometimes you mean what you say and you say what you mean. Am I correct? So let us see how these words are, the meaning of these words in relation to our topic. Principal root has something to do with positive and truth of a number. So a number has something like positive and negative number. But when we talk about principal root, we will talk about only the positive. It's the principal root. For example, 9 has a cube root, square root of 9. The positive root is, the principal root is positive 3 because 3 times 3 is 9. But remember, you can also have negative 3 times negative 3 is 9. So you can also have negative 3 as root, as the square root of 9. So you can have the positive and the negative root. Therefore, when we talk about the principal root, we will just talk about the positive root. So a perfect square, the square of a rational number. For example, square number. 1 is a square number because 1 times 1 is 1. 4 is a square number because 4 times 4, 2 times 2 is 4. You can tell a number in which you are going to multiply by itself 2 times, it will become 4. So rational number, a number that can be expressed in the form A over B over B, where A and B are integers and B is not equal to 0. So that's the condition. A rational number is a number whose decimal representation is neither terminating and nor repeating. This number cannot be expressed as a quotient of integers. So those are the words. I just wanted you to observe my examples, though these are very few. But I just wanted you to look at how is rational numbers compared to irrational numbers. What can you see about the root? About square root of 36 is 6. Square root of 81 is 9. Square root of 64 is 8. So what can you say about 6, 9, and 8? Those are rational roots or rational numbers. When it comes to irrational numbers, we have square root of 2. The root of square root of 2 is irrational because we have 1.4 blah blah blah. I just wanted you to look at the decimal places, the decimals, and how are they? Are they terminating? Are they? Is there an end to this one? What can you say about the numbers 4, 1, 4, 2, 3, 5? Is there a pattern? Are they the same? Are they different? That's how you are going to look at it. There are so many ways in which you are going to tell the rational numbers and irrational numbers, but this is my simple way of telling you how are they different. Now, actually, rational numbers, you notice that some principal roots are whole numbers while some are decimal numbers. That means when a principal root is a whole number or fraction, then the principal root is described as rational. Now, when a principal root is non-terminating or non-repeating decimal, then the principal root is described as irrational. Okay, so can you tell if this one is rational or irrational? Maybe you can look at the calculator and see the roots. By the roots you can tell, by the fruits I can say, by the roots you can tell if this one is rational or irrational. The root of square root of 49, square root of 3, square root of 50, square root of 26, square root of 81, square root of 121, square root of 25 over 64, square root of 12, square root of 144, square root of 6 over 21. Yan. So let us see. I know you're done. So here are the answers. If you have this kind of answer, then you got it all correctly. Okay, so I hope I made it clear to you. Now, to sum it up, for the rational and irrational numbers, a real number has that can be described as rational as or irrational. The square of a rational number is considered when a number is perfect square, then its principal root is when the principal root of a number is non-terminating or non-repeating decimal, then the principal root is described as again. When extracting the principal root of a real number, it can be described as Okay, so here are the choices. You can repeat or you can use the one word twice or more than once, just more than once. Okay, I think you can guess the correct word. And here's the correct answer. The correct answers are, ayan. A real number has principal root that can be described as rational or irrational. The square of a rational number is considered perfect square. When a number is perfect square, then its principal root is rational. When the principal root of a number is non-terminating or non-repeating decimal, then the principal root is described as irrational. When extracting the principal root of a real number, it can be described as either rational or irrational. Okay, look at this. Determine between what two consecutive integers the square root of a number like. There are times, how are we going to tell? Sometimes there's a way of checking if our answer is correct. Because there are times it's hard to there are times there you mistakenly press the wrong key. You press a key that is not correct for that particular number. So here is a way of determining if your answer is going to be correct. So for example, square root of 8. Square root of 8 is between the square root of 4 and square root of 9. 8 is not a perfect square, but it is between 4, which is a perfect square, and 9, which is also a perfect square. because it is perfect. When you square 3, it becomes 9. When you square 2, it becomes 4. But you can think of a number, an integer, which when you square becomes 8. So it is just between 2 and 3, and 4 and 9, like that. So therefore, square root of 8 lies on the integer 2 and 3. It is between 2 and 3. So all you have to do now is to give the square of a number. Square of 1, square of 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, 12, 13, 14, 15. So you can make use of your calculator. You can manually compute for this one. At a later time, this will be your assignment. So I just wanted you to attach the file. You can edit this part, and then I want you to give the correct answer from 2 until 15. So you will have 14 points with the additional of 1 point. That becomes 15 points already. So this will become 15 points for you. So watching this video and giving me this as attachment, this will give you 15 points already. Okay, so going forward, if a principal root is an irrational number, the easiest way you can do is to determine between what two integers the square root of a number lie. When you say integers, we have the counting numbers 1, 2, 3, 4, and the opposite of the counting numbers, we have negative 1, 2, 3, 4, and 0, of course. So think of two consecutive perfect square integers where 12 is in between of them. So 12 is in between 9 square. 9 is a perfect square. 12 is not a perfect square. But 16 is also a perfect square. So 12 is between them. Square root of 9 is 3. Square root of 16 is 4. Therefore, your 12, the square root of 12 is between square root of 9 and square root of 16, which is 3 and 4. Now, what about this? The more we practice solving problems, the more looking at the same problem on the previous one, the better, the lesser problem you have. Sabi nga nila, the more problem you solve, the lesser problem you have. Is it correct? In our case, in math, we never run out of problems. We keep solving problems, but there are more problems coming in, just like in real life, diba? Anyway, that's life. So just don't give up. Just don't give up. So what about square root of 77? Where can we find this? What are the two integers where we can locate square root of 77? Where does the principal root of this number lie? So what about square root of 87, square root of 50, square root of 136, square root of 243, square root of 6, square root of 160, square root of 94, square root of 118, square root of 159. I'm just having a short breath. Okay, so let's proceed. Question mark. Can we proceed? Okay, let's proceed. Okay, so this one is square root of 77 belongs to 8 and 9 because 8 times 8 is 64. So 77 in near 64 and 81. It's not yet 81. So here are the correct answers. I hope this can help you a lot in trying to understand what I'm trying to say to you. Okay, another thing is this. Oh, wow. There's already correct answer. You're lucky. I did not. So here are the something for you to match, but they already match it for you. So it's easier. So you try to understand square root of 8 is D. So 2 and 3. So you see that? So I hope you can understand the meaning of irrational number. Irrational number can still be understood with a rational number. something that a mystery can be understood by those things that you know already. Anything that we know can help us know what we do not know, something like that. So I hope you know. Okay, for the assessments already, just have to visit your Google Classroom. And then for your assignment, as I said earlier, you can edit this part and then attach it as a file in our Google Classroom. That's it. Thank you. I hope we will see each other on the synchronous level, synchronous time. Thank you, grade 7, and everybody who is watching and who needs this kind of video. Thank you again. I hope I learned. I hope I have shared something useful for you. Bye bye.